Hello and welcome. Today I'm going to show you how I designed this 3D printable model rocket engine mount in Fusion 360. Alrighty, before we can start designing our rocket engine mount in Fusion 360, we are going to need a few measurements of our engine as well as our fin can or body tube so we know what size to make the mount. So to do that, we're going to need a couple things. We're going to need a motor. So this is conveniently an A size motor. We're also going to need just a place to write down our measurements and a writing utensil and a way to measure our motor and fin can / body tube. You could use a ruler. I am not going to be using a ruler because I prefer to use calipers, specifically these digital calipers that I got from Harbor Freight. They're relatively inexpensive and have provided accurate measurements so far for my needs as well. I'm going to be using the millimeter increments, and I'm going to be using my fin can that I have already gone ahead and printed for my testbed rocket. The testbed rocket is just a platform that I use to test different components and parts and fitments and measurements and things before I print them for an actual rocket. I mainly test it for design. So for example, this spiky fin design with the forward swept fins, I tested just to see how the printing process would go and how well it would be rigidity wise at a 15% infill, and so far it's pretty good, but that's besides the point. But we'll be using this for our measurements as if we were going to make a motor mount to fit a motor with inside this fin can here. So I'm going to set this off to the side. I'm going to hold the motor here for now and move these off to the side as well to give us a little bit more room. So let's go ahead and reorganize and write down what we need measurements of. We need measurements of the length of our motor, as well as the diameter of our motor, as well as the inner diameter of our motor. Please ignore my handwriting. And then, so I'm going to write motor measurements. And I'm going to write the engine that I used, A8-3, so that way I can reference this if I need to again. I'm going to draw some squiggles. I'm going to write fin can measurements. And again, we're going to write down length of the fin can as well as the diameter. Yes, that says diameter, and we'll also need our inner diameter. Okay, excellent. So let's go ahead and start with the engine or the motor. I never know what to call it. I interchange those. So let's grab our length and kind of bouncing around 69.9. So we're going to just round up to 70 millimeters. That'll help us if there's any defects in manufacturing. That'll change the size of it. Okay, let's grab the diameter of the motor, kind of spin it around a little bit, kind of dancing between 7.3 and 7.4. Again, we're going to round up to probably 17.5 millimeters. And then the inner diameter, you can do it one of two ways. You can grab the thickness of this guy and then do some math. Or what I prefer is to just use the inside measuring part of the caliper. Don't go on the nozzle. Whoopsies! Don't go on the nozzle side. You'll damage it and get an inaccurate reading. Just go ahead, go into the top. Again, kind of twist it around just to get some different sizes and things. And yeah, let's do 12.6 millimeters. Okay, good average. Use the term average loosely. All right, so here's our fin can. We're going to take the inside diameter and then the length, and then the outside diameter. So let's grab the inside diameter. Whoop. And 29.75 seems to be where we're landing. Just about a little bigger on that side, a little smaller on this side. Could just be how I'm measuring. Make sure it's 29.8. 29.8. Let's do 30 millimeters. The inside diameter. Give us some wiggle room and some room for glue. Let's grab our diameter. Okay, we are 41.17. 41. Let's do 41. Now we're grabbing this outside diameter, because if we were to take a look at our retaining nut, this flange that we see here, if we screw this on real quick, just loosely, this flange that we have will sit up against this bottom lip of the fin can to help push the rocket up. Then my plan is to have either some screws or some light glue just to keep the motor in place during flight, and that'll come with some experiments as well. So now let's do our length. Now we already have our length of the motor of 70 millimeters, and if we take our motor and pop on the fin can, we know that we have some room, which is good. But I do want to design, if I angle this right, you might be able to see a kind of a little ridge, and that rests up against the cardboard of the motor, and it's not allowing the motor to push through. And I want that to be about 1 millimeter to 2 thick, just for strength. So I'm going to do 72 millimeters for that ridge portion. So now we have all our measurements that we will need for our CAD designing process. So I will see you over on the computer. All right, so what I have here is the fin can that we are designing our motor mount for. It may look a little different than the one that I used in the video of taking the measurements, but that is because I was trying some fillet designs and chopped off the tips just to give it a more rounded appearance. But that's besides the point, so let's go ahead and create a new design here. And I'm going to get started by creating a sketch. And I'm going to create a sketch on this bottom plane with the green and the red axis. So click that, and then I'm going to create a circle, put it into the center just to make everything reference easier later. So I'm going to give this the diameter of our motor mount, which will be the inner diameter of our fin can, which is conveniently 30 millimeters. Perfect. So now that we have our measurement of our motor mount, I'm going to finish the sketch. Okay? And I'm going to extrude this to the length of our fin can measurement that we took earlier, which is the length of our motor plus about 2 millimeters, and that is 72 millimeters. Okay, now it's starting to take shape. Okay, so let's go ahead, and to make our lives a little easier, I'm going to construct a offset plane based off of this plane right here, the same plane that we used, and I'm going to raise it up the same distance, 72 millimeters. So that will give us a plane at the top of our cylinder here. So let's go ahead and create another sketch, grabbing our offset plane, grabbing our circle tool. We're going to draw another circle with the diameter of our motor, which is 17.5 millimeters. Finish the sketch, extrude, and pull it down. Length doesn't matter as long as we have it as a cut operation, and click OK. Alrighty, so now we have our basic motor mount created. So let's go ahead and click home and top, reorient it a little bit, and hit this guy, and then back to this guy. There we go. Took me a second to get this orientation back. I'm no means a Fusion 360 expert. I'm just showing you the steps I took to create my motor mount. So I'm going to go ahead and hit save. I'm going to call it motor mount, and then the name of the engine A8-3, just so we know what engine we are talking about. And then I'm going to put in parentheses the name of my fin can, which is 4-fin spike can. That way I can reference things. Oops. 4FN? No, it's 4-fin can. And save. And I save this now because we are going to just check our measurements before we get too far. So I'm going to come back to our 4-fin spike can. I'm going to hit bodies and hide all the fins. Just leave the can. And I'm actually going to hide the can for now. Then I'm going to click on the waffle here in the upper left corner, and I'm going to insert into current design. And it brings it in, and I'm just going to enter so it's right in the center. Then I'm going to show our can. Going to hit the inspect tool, section analysis. This will allow us to see inside. I'm going to pick this plane here and take a peek. We can change the size, but I'm going to leave it now and just orbit. And look at that. We have a fin can that nestles in quite nicely. Doesn't look too bad. Oh, that's just the tool throwing that off. Yeah, not too bad at all. Front. Ooh, this way. So yeah, looks like we're on the right track. So let's go ahead and I'm going to save this. Insert motor mount. Insert note. Hit OK. And as we make changes, we can come back to this and update our version, and we can see how we are doing. So let's go back to here and close this. Now let's go ahead and create the top of our motor mount, which will help retain the engine when it's producing thrust. So let's go ahead and hit construction and view our offset plane again. We're going to create a sketch, and we're going to hit that button. We're going to again create a circle at the center, and it's going to be 30 millimeters. Okay, excellent. Then we're going to create another circle, and this will be the inner diameter of our motor mount. So let's give that a 12.6. That's not correct. 12.6. There we go. Finish our sketch. Grab our extrude tool. Select the center, and let's give it 2 millimeters. Enter. Now let's just peek in here a little bit. Section analysis. Again, my favorite side. And we can see how we have our lip here at the top to retain the motor when it's producing thrust for us. So let's go ahead and hit exit here just to turn that off for a second. And now let's go ahead and recreate the retaining ring. Now this part's a little tricky, and I'm going to be turning on and off different bodies and sketches just to help us see a little better. So I'm going to click the top of our cube, orientation cube. I'm going to actually turn off our body, which I will call motor mount, just to be semantic. Turn that off. We still have this for some reason. I don't know why, I'm not an expert. Okay, so now we are going to create another circle. Lots of circles here. We're going to create it as the diameter of our fin can, which is 41 millimeters. Okay, and we're done. I'm just kidding. So what we're going to do now is we're going to create another circle, and that diameter is going to be the inner diameter of our motor, so 12.6. And this is where the thrust will be coming out of. Okay, so now we are done, so let's finish the sketch. and rotate just a little bit. We're going to extrude, but we're going to be extruding down in this case. I'm going to do 2 millimeters. Okay, so now we have our like a washer, and if we turn on our motor mount, we can see that it sits on top of it real nice. So let's get our isometric view back again, and I'm going to hit save and top and bottom. Okay, we are almost done. You could stop here if you are planning just to glue the motor inside of your motor mount, but you won't get the nice thread option to take off the retaining ring, put the engine in, close the retaining ring, and be able to reuse this a couple times potentially. So now that that has saved, let's go back to our FinCan, and we'll notice that our inserted motor mount reference is saying, hey, you have a new version. So let's go ahead and orient ourselves a little bit here. Right click and, excuse me, get latest version. There it is, right here. So let's grab that. And as it updates, we'll see not only the lip, but our retaining ring. And we can see how it fits quite nicely. It's a little bit smaller, but that's okay. It's not meant to be perfect, a perfect match. Must have been an inaccuracy while measuring, but that's fine. But we can see how it'll create that lip. So now we're going to create the thread for this guy. So let's go ahead and do that now by first saving this. New version. I cannot type today. There we go. Go back in here. Turn off our motor mount. We're going to create a sketch and plop that in there. Okay, so now we are going to create yet another circle. Now, going to turn on the body just so we can see where our current motor mount circle is, because we want our threads to be in the middle, roughly. So I'm going to create a measurement, and it's giving us 20 to kind of be between the middle of here and there. So 20 seems to be about the middle between the 2 points. And I think that's a good spot for it. So I'm going to put it there. Okay, then, so now we're going to need to create our threads, or space for our threads. I'm going to do 22 millimeters, so it'll be a 2 millimeter thick portion for us. I'll hide our body and hit finish. And I'm going to extrude our new body. 2, 3, 4, let's do 5 millimeters. Just take a peek how big it is. Yep, that should be good. And we are going to hit OK. So now if we turn on our motor mount and inspect, we're going to see something. We're going to see our lip poking up in there. Pretty cool, right? So let's go ahead and add some threads. Let's turn that off. I'm going to turn body 2, which I'm going to rename as retain ring. I cannot spell either today. Retain ring. I'm going to turn it off and take a peek, and we don't have anything in here. But that's okay, because we know our measurements from earlier, so we're going to create a cavity for that to sit in. So I'm going to create a sketch and select the bottom here. Go here, 20 millimeters. Go here, 22. Finish. Okay. Orient it a little bit so I can see. And we are going up 5 millimeters. And it is cut. There we go. So now we have a space for our threads. And again, we're going to turn on our retaining ring. get situated here, zoom out, get our section analysis, select our axes, and we can turn this off and on and off and see that everything is as it should be. So far so good. So let's go ahead. I'm going to leave our section analysis here so we can see our threads without having to jump back and forth. But I'm going to turn off our motor mount and go ahead and position this, grab this face, the outside face, go through and click a thread. And make sure you click the modeled button here so it doesn't just pretend it's a thread, but it actually creates a thread. Okay, see that it is too thick. Okay, perfect. So I just picked a number that looked good and what would print a good thread, 12.5. And before I hit OK, I'm going to hit Remember Size. This is important so that when we create the other threads in the motor mount, it'll line up correctly. Hit Remember Size and click OK. Excellent. So if we turn on our thing, we'll notice that our threads cut in real thick here off our body. So let's turn off our retaining ring and click this inside face. Go here to create and thread. And since it remembered our size, we're just going to click OK. And if we turn on our retaining ring, look at that. We have threads. Now I've ran into an issue where if I don't offset the thread faces a little bit, that when I print this, these threads will be really tight and it'll bind up and be kind of a pain to screw on and off. So let's go ahead and add some offset. So I'm going to turn off the motor mount here. Then I'm going to hit Q to bring up the offset face, and I want to do a negative distance to increase the clearance. And I want to do a negative 0.1. So just a little bit. Hit OK, and then I'm going to just rotate this about just to make it a little easier. Hit the bottom part of the thread, hit Q, and offset this one, a negative 0.1. Now if we notice, that creates a really sharp screw plane, and it kind of gets kind of funky over here, as you can see. So let's not do 0.1 here. Let's just do 0.01. I think that'll be enough. Or we can do 0.05. I think that'll be perfect. Hit OK. Bring our orientation about. Zoom out. We'll bring in our motor mount. And let's take a peek. You can see our clearance that we have created. Excellent. So let's go ahead and save. Added threads. Hit OK. So far so good. Let's bring this in. Click on it. Grab the latest version. And ta-da! We have our threaded motor mount put in here as well. So as part of my design that I'm still working out is I want to figure out how to get holes drilled into here so we can put some as part of my design, I want to figure out how to get holes drilled into here so we can attach the mount to the fin can more securely. I was also thinking of a way to attach it in from the top as well, but that's another video. So I hope this was helpful, and please take what you've learned today with a grain of salt, as I am not a Fusion 360 wizard. I just figured this out by playing around with some different settings and watching tutorials like this on YouTube. So please let me know what you think, and have a great day. Bye-bye.